All right, so let's continue with today's work. So today we're gonna look at the link, the EtherChannel and link aggregation. So we're still continuing with our topology that we've designed. Now here's the problem: one link is never enough, right? So here's a scenario. Let's say it's a month end at Elpda Solutions Johannesburg head office. The finance team is running payroll, and then HR is generating their monthly reports, and the IT department is doing backup on a file server. All of them are pushing data through a single 1 gigabit trunk link between switch 1 and switch 2. That link is saturated. So finance is experiencing slow transfers, and then HR reports are timing out, and then the IT backup is going to take 4 hours instead of 1, and then the IT manager calls you and says, well, we need more bandwidth between these switches now. So you have two options. Option 1, upgrade to a 10 gigabit link. So you call your supplier, the 10 gigabit, SF P plus modules cost about 8,000 each, and the switches needs compatible slots. Now the total cost is 16,000 minimum, and then 2 weeks delivery time. The finance manager is not going to wait for 2 weeks. Option 2, you walk through the server room, you open a cable rack, and then you pull out 4 standard Cat 6 cables. You plug them between switch 1 and switch 2, and then and type 10 lines of configurations. So, well, the cost is essentially 0. Time it takes maybe 20 minutes. Results, you get 4 gigabits of bandwidth between the switches. So that's 4 times what you had before. So this is EtherChannel. Now, enterprise networking hardware is significantly more expensive than international prices due to import duties, you know that, and VAT and things like that, and limited local stock. So a single Cisco 10G SFP plus transceiver retails for about 6,000 to 25,000 at distributors like Duxbury Networking and Drive Control corporations. And then EtherChannel using existing GIG ports costs nothing extra. I mean, for in SME and schools, so the cost difference is just is difference between a project happening or not. Now, what EtherChannel actually does, EtherChannel, also called link aggregation or port channel, bundles multiple physical Ethernet links into one logical link to all other network devices, including STP as well. So the bundle looks like a single interface. So the benefits are, it's a threefold. First, bandwidth. 4 1G links bundled is equals to 4 gigabits of local logical bandwidth. And then secondly, redundancy. If one physical link in the bundle fails, traffic automatically redistributes across the remaining links with no reconvergence. So no STP topology change, no 30-second delay. And then number 3, STP efficiency as well. It sees one logical link, not 4, and then physical links, so it doesn't block any of them. All 4 cables carry traffic simultaneously. Now let's talk about PAgP and LACP. So those are the 2 EtherChannel protocols. So before we configure anything, you need to understand the 2 protocols that is used to negotiate and maintain EtherChannel bundles. Starting with PAgP and LACP. Now, PAgP, that's a port aggregation protocol. So in a Cisco it's a Cisco proprietary EtherChannel negotiation protocol. So it works between Cisco switches. So if you have a Cisco switch on both ends, and then it works perfectly, but in a mixed vendor environment, say a Cisco switch talking to a Aruba switch or something like that, then it will not work at all because the other switch does not understand it. So it does have two modes. There's a desirable mode, which means that the switch actively tries to form an EtherChannel. It sends a PAgP negotiation packets. And then there's auto, which means that the switch passively waits and it will form a channel if the other channel end initiates, but it will not start the conversation itself. And then now the link aggregation control protocol is an IEEE 802.3 AD standard, open standard. It works between any vendor switches, whether it's a Cisco or it's HPE or Huawei or Jupiter or Aruba. Yeah, I mean, in modern enterprise networks and in South Africa, where mixed vendor environments are extremely common, so LACP is a preferred choice. So LACP has two modes. Active means that the switch actively sends LACP packets to initiate and maintain the channel, and then the passive just means the switch waits for other end to initiate, just like PAgP. So it's just two passive switches will never form a channel. Now, there's also a third option, on mode. So this forces the channel to form without any negotiation protocol. So there is no PGAP packets, no LACP packets. So the ports just bundle together statically, and then both ends must be sent on, and both ends must have identical configuration. So if one end is on and the other one is running PAgP and the other one or LACP, then the channel will not form. So on mode is rare in modern networks, but it is tested on, I mean, if you take your CCNA exam. So the thing is, government departments, maybe including CETA and professional health departments, they often run mixed environments because of the different procurement cycles, you know, buying Cisco, Huawei, HPE, Aruba, and at different times. So LACP is only EtherChannel protocol that works across all of these vendors. So, and any of the engineer working in government ICT must understand LACP deeply. Now, for EtherChannel, what requirements do we need? Before we configure EtherChannel, I need to teach you most important rule. So the rule that causes 90% of EtherChannel failures in the real world and also in the exam lab. So all member ports in the EtherChannel bundle must have identical configuration, right? Not similar, not almost the same, but identical. So the switch checks every parameter before agreeing to bundle the ports. So if any parameter mismatches between the ports, then the channel simply does not form. So there's no error, there's no warning. It just silently fails to bundle. Right? So this is what makes EtherChannel troubleshooting so frustrating. So you must check like speed. The speed must match. The duplex mode must match. The VLAN membership must match. The VLAN, trunk allowed VLANs must match, and then switch port mode must match. So both must be set to trunk. And then native VLAN must also be native VLAN 1. Because example of mismatch, if maybe one native VLAN 1 and then other is native VLAN 99. All right. The most common EtherChannel failure in labs, maybe in student labs, is configuring a trunk allowed VLANs on one switch but forgetting to match them on the other. You know, so both switches needs a switch port trunk allowed VLAN 10, 20, and 30, not just one side. So if they differ, then the channel forms, but some VLAN traffic is silently dropped. All right, now let's go ahead to the lab and build that. Now we still have our topology, which is switch 1 and switch 2 currently have a single trunk link on gigabit Ethernet 01 on both switches, right? So we're going to add 3 more cables between them, giving us a total 4. and then bungled all four into the EtherChannel. So we use FastEthernet port 23 and 24 for 2 more links, and then keep G0/1 as a third. Actually, for a cleaner lab, let us use FastEthernet 21, 22, and 23 and 24. All right, for all of the EtherChannel links, and then repurpose G0/1 for something else. So this way, all 4 bundled ports are on consistent FastEthernet interfaces. All right, now we need to add 4 crossover cables between switch 1 and switch 2, so which is FastEthernet 21 to FastEthernet 21, and then FastEthernet 22 to FastEthernet 22, FastEthernet 23 to FastEthernet 23, and then so on until 24. All right, let's quickly do that. So we need to add crossover cables. So I'm gonna go to the cables, and I'm gonna just, so we do FastEthernet, we start on 21 to FastEthernet 21. Okay, maybe I move this a little bit. Then we do the same thing, 22 to 22, and then 23 to 23. And then the last one is 24 to 24. Now, if we look at the topology right now, it's 4 parallel cables between switch 1 and switch 2. It's beautiful, but it's dangerous without EtherChannel. No, because right now STP just sees 4 separate trunk links, and it's probably blocking 3 of them. Anyway, so they are actually blocked. So we are paying for 4 cables and getting bandwidth of 1. So EtherChannel fixes this. All right, all 4 will be active simultaneously. Now let's go ahead and configure a LACP EtherChannel on switch 1. So I'm gonna go to switch 1. So we will use LACP for our EtherChannel. So the open standard best practice for enterprise that may add on non-Cisco switches in future. So we will enable and then configure terminal. So step 1, the first step is to configure the 4 member interfaces using interface range to configure all 4 at once. So we can just say interface range FastEthernet 0/21 to 24. And then switch port, fix the spelling there, switch port mode trunk. And then switch port trunk allowed VLAN 10, 20, and 30. And then channel group 1 mode active. And then step 2 is to configure the port channel logical interface. So this is where you set your trunk properties for the bundle. So we can just say interface port channel 1. Did I get any spelling mistake? Interface port channel, oh, port channel is hyphen, yeah, sorry, it's port hyphen channel 1. All right, and then we can say switch port mode trunk, and then switch port trunk allowed, so it's VLAN 10, 20, and 30. Okay, and then we end. All right, now let me just walk you through everything, every important line here. So the interface range FastEthernet 0/21 to 24. This is a powerful command that lets us configure 4 interfaces simultaneously. So everything that we type next applies to all 4 at once. So this saves time and, more importantly, it guarantees identical configuration across all member ports. And then switch port mode trunk and switch port trunk allowed VLAN 10, 20, 30. We are making all 4 ports trunks, allowing our 3 VLANs. So this must match exactly it has to match exactly on switch 2. So we're gonna do the same thing on switch 2. Now channel group 1 mode active. This is the EtherChannel command, which is a channel group 1, which assign these ports to EtherChannel bundle 1, and then the number 1 is locally significant. So it just identifies which bundle on this, on this switch. So mode active means LACP active. So this switch will actively send LACP negotiation packets and just try to inform the channel with other end. And then interface port channel 1. This is a logical interface that represents the entire bundle when you configure the port channel interface. So those settings apply to the entire bundle, so we must also configure it as a trunk, allowing our VLANs. All right, so the port channel interface and the physical member interface, they must both be configured consistently. All right, now let's go ahead and do the same thing on switch 2. So I'm just gonna go to switch 2. Enable, and then configure terminal, and then we mirror the configuration on switch 1. So let's interface range FastEthernet 0/21 to 24, and then switch port mode trunk. All right, and then switch port mode trunk allowed VLAN 10, 20, and 30. Okay, let me fix my spelling before I run this. All right, and then interface port. Oh no, we have to do channel group. All right, and then interface port channel 1, and then switch port mode a trunk, and then switch a port trunk allowed VLAN 10, 20 and 30, and then and so both sides are now configured as LACP active. So active plus active equals a channel that forms. So within a few seconds of typing these commands, the four physical links will negotiate and then bundle together into port channel 1. So if we go and show ether channel summary, I think I got the spelling channel wrong. Channel, then we can see that port SU is up. So the first column shows PO1, port channel 1, and next to it you see the flags in brackets. So the flags that you want to see is SU. S means the port channel is layer 2, and then U means that it's in use and it's actively forwarding. So if you see SD like we did yesterday, the D means down. Alright, so the channel is not forming. So that is your first sign of a problem. And then below PO1, then you're gonna see each member is listed, which is FA0/21, FA0/22, 0/23, and then 24. Each one should have the flag P, which means that the port is bungled and is just participating in the channel. So if the port shows I, independent, it means that the specific port has failed maybe to join that bungle. So usually because of the configuration mismatch and things like that, member links. The next command is to show spanning tree. Spanning tree VLAN 10. You can compare this to what we saw before with EtherChannel before for separate FA021 to 24 interfaces. So 3 of them were blocked by STP, if you remember, and then after, then one port channel 1 interface showing as a designated port. So basically the STP just sees a single 4 gigabit logical link. Okay, there's no blocking that is needed. So all 4 physical cables are carrying one traffic simultaneously. So the bandwidth is not shown here, but you can verify by show interfaces port channel 1 So the port channel, I think, is a hyphen. It's a hyphened word. Port channel 1. Alright, let's just get into the switch by enable, and then, because I don't understand now why some of these things are not working. Show oh, it's interface. Why did I say interface? Yeah, but it's interfaces, isn't it? Show interfaces, port channel 1. I think it's supposed to be like that. Oh, there we go. So you must just enable the switch. So there it is. The bandwidth field just shows the aggregated capacity of 400, capacity of 4 links combined. So in the packet tracer, the port simulates 100 megabits per second. So each, you'll see that each is actually, so you will see 400 megabits per second, because it just simulates. You see that it actually simulates 100 megabits per second, not 1 gigabit per second. So we actually see 400 megabits per second. But in real Cisco 2960 with 1G port, you will see 4 gigabits per second. For 0 additional hardware costs. Now let's verify. Let's verify all VLANs still work across the bundle, because the thing is, EtherChannel carries 802.1q tech trunk frame, so all the 3 of our VLANs should still work perfectly. So we can just verify by going to Finance PC, and then we ping. So let's go to Finance PC 1, and then we can just ping PC2. Not terminal. Command prompt. So we can just ping in the same switch, right? So we can just ping 10.10.1.11. So that's in the same switch. And then PC2 is replying, and then we can also ping HR across the EtherChannel bundle. So from PC1, so we can ping HR PC1. So that will be ping 10.10.2.10. And then test 3, we can ping ITPC. So we can just ping 10.10.3.10. So all 3 VLANs, Finance, HR, and IT, are flowing perfectly across the EtherChannel bundle. So the VLAN 10 traffic, the VLAN 20 traffic, the VLAN 30 traffic, all tagged with 802.1q, all load balanced across the 4 physical links simultaneously. So one last important concept is load balancing. How does the switch decide which physical link is in the bundle to use for each frame? So this is called a load balancing method, and it is configurable. So by default, Cisco switches use source MAC address to decide, and then all frames from the same source device go out in the same physical link. So this just keeps the frames from a single conversation in order, but you can change this to optimize for your traffic patterns. So for our network, which carries both switch VLAN and routed inter VLAN traffic, the best option is the source destination MAC for switch to switch link. So we can configure it globally on the switch. So on Johannesburg switch 2. Let's go to switch 2. We can do this. enable, and then configure terminal. And then we will say port channel load balance, and then source to destination is gonna be MAC address. Sorry, it's a destination, DST, DST. All right, then we can verify, show either channel load balance. So let's just recap of what we've done. We started with the real world problem, maybe month-end bandwidth saturation at Johannesburg headquarters, and show that the EtherChannel gives you 4 gigabits of bandwidth for the cost of Cat6 cables and 10 minutes of configuration. So we went deep on PAgP versus LACP, which is basically a Cisco proprietary versus open IEEE standard, and the mode combination that you must know, for example. So we also covered the matching requirements that cause 90% of EtherChannel failures. So we configured LACP between switch 1 and switch 2 using 4 links, channel group 1, mode active on both sides, and then we also configured so we actually verified, we also configured the load balancing, and then we also verified with show Ethernet summary. So this actually completes the layer 2 switching block of our course through all of these lessons that we've covered, from packet tracer setup, OSI model, IP addressing, VLSM, VLANs, inter-VLAN routing, spanning tree protocol, and EtherChannel. Now we have fully built enterprise grade layer 2 and layer 3 switching infrastructure for the office. Now in the next lesson we move up the stack to static routing. So we revisit our WAN links between Johannesburg, Cape Town, and Durban, and add a proper static routing so that PCs in all the 3 offices can reach each other. All right, so that's what I actually forgot about, that we haven't done. I thought we've already done it. On that lesson, it actually takes it a little bit further with OSPF, or dynamic routing, that adapts automatically when the link goes down, so the network gets smarter from here. So yeah, so anyway, let's end here for today.